Hello everyone, in this video tutorial I'll be taking you through wireless sensor network applications. Wireless sensor network can be applied onto different areas starting with military, environmental, health, home and industrial. Under military we have different applications like smart dust, sniper detection, VigilNet, and under environment we have examples like illustration examples like Great Duck Island, ZebraNet, volcano monitoring, flood detection, and under health we are having patient monitoring system. Under home we are having water monitoring system, and under industrial we are again having VigilNet and structural health monitoring system. Wireless sensor networks can be an integral part of military command, control, communication, computing. C to the power 4, that which consists of command, control, communication, computing, followed by intelligence, surveillance, reconnaissance and targeting ISRT systems. Rapid development and self-organization and fault tolerance characteristic of sensor nodes make them a very promising sensing technique for military C4 ISRT. Better approach for battles because sensor networks are based on dense deployment of disposable and low-cost sensor nodes. Destruction of some nodes by hostile action does not affect a military operation. So let's take up the very first application, that which is smart dust for military. Smart dust was one of the earliest application of wireless sensor network phenomena. The main goal of this DARPA funded project was to use wireless sensor network, extend the reach by deploying these networks in the areas where it is too dangerous for humans to operate continuously. Military applications include collecting information from enemy movements and detection of hazardous chemicals. The main goal of the Smart Dust project has been deploying sensor platforms in cubic millimeter packages. Sensor node is a 100 cubic millimeter prototype which has two chips, MEMS, corner cube optical transmitter array, where MEMS is micro electro mechanical switches, and CMOS ASIC with an optical receiver. So these two chips you can find it in a 100 cubic millimeter sensor node. Smart Dust project has resulted in creation of dust networks. The next application is sniper detection system. Boomerang sniper detection system has been developed for accurate sniper location detection by pinpointing small arms fire from shooter. It has been used by military as well as it's also used in law enforcement agencies and municipalities. Counter sniper system consists of an array of microphones. So this is the array of microphones and can be mounted on a vehicle or worn by a soldier. So this can be mounted on the top of a car. System uses passive acoustic sensors. Acoustic means sound, anything that which is related with sound, and here the system is making use of sound sensors to detect incoming fire. Detected audio from these microphones is processed in order to estimate the relative position of the shooter. Vehicle mounted sensors can even detect shooter even while they are moving. This centralized concept has been enhanced through distributed network of acoustic sensors, and this led to the formation of this kind of system where these passive acoustic sensors boomerang have been deployed across a network in a distributed system. Once a shot has been detected by several sensors, the time and location information of these sensors is used to determine the trajectory of the bullet. And when the trajectory of the bullet is estimated, the location of the shooter is also got. Followed by, it's also used in VigilNet. And this VigilNet also applies for industrial application. And this is a very large scale surveillance network designed for stealthy target tracking in harsh environments. So stealthy is something that which is hiding. So basically in battlegrounds, enemies try to attack by hiding, and it is used to track such stealthy hidden enemy kind of objects. So design and implementation of the network is based on Mica 2 nodes equipped with magnetic sensors, and these magnetic sensors will detect magnetic field generated by the movement of any vehicles. And the lifetime of VigilNet is improved by adopting hierarchical architecture. Similar to that of Leech protocol, that which makes use of hierarchical architecture. Here also, uh, through neighborhood discovery, century selection will be done, and in turn, this is made to go through an entire cycle. So here we have down here we have a reset. After resetting, system initialization happens, followed by neighbor discovery. After neighbor discovery, sentry selection happens, and sentry is a person who has been deployed to vigilate, and he'll be sending the status report. And after that, if at all if there is any event happening, event tracking will happen, and this is happening parallelly with power management. And again, if there is no activity detected, again the system resets, and again this cycle repeats, where different sentry node will be made to vigilate. So that's about military application. Coming on to the environmental application, here tracking the movement. So under environmental applications, we are having vast variety of applications, starting with tracking movement of birds, small animals and insects, monitoring environmental conditions that affect crops and livestock, followed by irrigation. It's also used in precision agriculture, forest fire detection, flood detection, and pollution studies. And one of such main example of application of wireless sensor network in environmental application is Great Duck Island, and this was done as a collaboration project between College of Atlantic and Intel Research Laboratory at Berkeley to study the distribution and abundance of seabirds on Great Duck Island. So here seabirds are a kind of birds that which are abundantly found in Great Duck Island. A network of Mica sensor is used to measure the occupancy of nesting burrows. So here, this is where Mica 2 sensors will be deployed, and they form a cluster, and these clusters that which are forming these nodes that which form clusters, we'll call it as tier 1, and at second level, that is tier 2 level, we have the bits that which collects the aggregated data and will be in turn passed on to the system. So this is a two-tier architecture of Great Duck Island Habitat Monitoring Network. So this is Habitat Monitoring Network. Then we have these ZebraNet, and this is basically an animal tracking system developed to investigate long-term movement patterns of zebras, their interaction within and between species, as well as impact of humans on these zebras. ZebraNet consists of collars attached to zebras to collect location information. Each collar includes GPS unit in order to track their location, associated microcontroller, two types of radios, short range and long range, and a lithium ion polymer high energy density battery, and a solar array for recharging the battery, lithium ion polymer battery. Then we have, in a similar way, we have volcano monitoring system and early flood monitoring system. And basically in early flood monitoring system, we'll make use of again different clusters will be there in tier 1, and again in tier 2 we'll be having coordinators, gateways as well as coordinators, and in turn we'll be having government as well as government section has one more node, and community home is the other point where if at all if there is any flood happening, it is monitored and informed to the corresponding authorities. And basically this study was done on by MIT Hondrasu, and here at the government office it makes use of an interface wherein we can visualize the data collected from different sensors that which are deployed. And to mention a few sensors that which are deployed, here we have rainfall and temperature sensor as well as water flow sensor. So these are all the sensors that which will be deployed, and in turn these sensors will communicate with the computation node, where in the computation mode prediction model will be done, that which estimates the river flow. And also these computation nodes are also used for long haul communication purpose. And this prediction model that which is running on computation node is basically a prediction model validated by 7 years, where study was conducted on Blue River, Oklahoma. And then we have under home application water monitoring system, where this is the water company, and through water company it will be made, the water will be dispatched on to different lanes where different community areas will be there. And over here this system is called as non-intrusive autonomous water monitoring system, NAWMS architecture, non-intrusive autonomous water monitoring system. The main goal of NWAMS is to localize the wastage in water usage and inform tenants about more efficient usage. Since water utility companies only provide total water usage in a home, it is not easy to determine the individual sources that contribute to the total. Using a distributed wireless network, sensor network, we can monitor water usage in each pipe of the house's plumbing system, and these can be monitored at a low cost. So these are all the application areas. And in a similar way, we have this under health, we have patient monitoring system, that which contains medical personnel who will be monitoring the PDA or through computer. He'll be getting all the data from the infrastructure node, and these infrastructures are in turn connected to various sensor nodes, and these sensor nodes actually work on publisher subscriber model. And the protocol used is ADMR, that which is an acronym for Adaptive Demand Drive Multicast Routing. So here sensor boards basically monitor various parameters like pulse oximeter. Like various sensor boards used here are pulse oximeter, electrocardiograph and electromyograph circuitry, and these are all designed for Mica Z boards. And here various parameters of human body measured are pulse rate, blood oxygen saturation, electrical activity of the heart, patient movements and muscular activity. And this entire project is given a name called as Code Blue project, and it is conducted at Harvard University, and it focuses on wearable sensors. AlarmNet is a similar kind of monitoring system which is specifically meant for elderly people with assisted living and residential monitoring application.